I've used PGlite to create a simple React web application. PGlite is a version of the PostgreSQL database. It is entirely embeddable in the browser and runs local first. To create this demo, I'm using as a starting point the Create Vite TypeScript template. A link to this demo and the source code are available in the video description. What makes this demo interesting is that all state is maintained in the database and the user interface is updated through live queries. This minimizes the need to maintain React state. What we have here is a series of emoji buttons, and when clicked, a click count will occur and a confetti effect is made. Below these buttons is an SQL read eval print loop, or REPL. And below the REPL are a series of sample SQL queries that can be run directly in the browser. Let's take a look at the entries in the fruit table. We have an ID, which is simply the emoji text, and the date at which it was created. Let's take a look at the click table. We see the most recent clicks, and if we add a couple more clicks and repeat that query, we will see those clicks recorded. We have as an ID for the click a UUID version 4, automatically generated ID. We have a referenced column, the on column, for the fruit on which the click was made. And we have the at column to record what time the click was made. What's interesting about maintaining state in the database and using live queries to update state is that if we insert a click into the click table through the REPL, we will see an increment in the click count on the button, and we will see the confetti effect. And we can repeat that as many times as we want, and we see the coconut click count increase. If we insert multiple clicks at the same time, we'll see multiple confetti effects. Both the click count and confetti effects are maintained through live queries instead of React state. We can make an entry into the fruit column, say for a tomato, and the button count will automatically increase, and we see our tomato button and we can click on it. We can remove the clicks for a particular button, and we'll see the tomato count go from 2 to 0. And we can remove a fruit from the table, and we will see the button automatically remove. And finally, we can delete all the clicks, and we'll see the click counts go to 0. In this demonstration, I've set up PGlite as a multi-tab worker. That means actions in one tab will be carried over into the other automatically. A click on one emoji button will do the confetti effect and the click count in the other, and vice versa. Now I'd like to show you the code. Again, a link to this demo and the source code are in the video description. Let's take a look at app.tsx. In app.tsx, we'll set one of the few pieces of React state used for the database itself. We'll use state, and because the database can only be initialized one time for the entire application, we'll use effect to initialize it. We'll use a PGlite worker, which is the multi-tab worker, and we will add the live extension that enables live queries. Then we will run database migrations, setting up our fruit and click table. Once that's been done, we'll use the setDB function to assign the DB worker to the DB variable. And we will use the existence of the DB variable to provide either a load PGlite message or the application itself. There is a PGlite provider provided by PGlite React, and we will use the database variable there and also use the DB variable in the REPL. We have the confetti effect component and the counters component. And below the buttons and the REPL, we have this copyable code that allows us to show some sample SQL queries. Let's take a look at counters first, and then we'll look at confetti. In counters TSX, we use the use PGlite handler provided by the PGlite React library. We can specify our live query, and this is standard SQL. We select from the fruit table first, and we do a left outer join to clicks. This will give us every row in the fruit table so that we can show a 0 unless there's a click count. We have a click function that will be our onClick handler. And in the click function, we insert into the click value for the emoji in question. In this component, we take the click count rows from the live query above and we iterate over them, providing a button with the emoji ID and the count from the query. Whenever the live query updates, the buttons will be updated along with the click count. Now let's take a look at the confetti component. The confetti component also uses live queries to produce its effects. It uses the live incremental query, also provided by the PGlite React library. Use live incremental query makes some effort to update only when entries have changed in the table. This live query will select from the click table the most recent by date 20 rows. This allows us to take a look at not just the most recent entry, but if multiple clicks are made at the same time as we demonstrated in the database REPL, then we can show a confetti effect for all those entries. Whenever an entry is made into the click table, the live query updates. When we get those changes, we iterate through the rows, we reverse them so that we show the confetti in the order that it was produced. We're descending on the query and reversing it in iteration. And we use the JS confetti library to add one piece of confetti for every click that is made. When a click is made, we update one of the other few pieces of React state, this last click, where we use a use ref so that it doesn't interact with rendering. What this avoids is showing a piece of confetti when we've simply deleted a click from the table. if the most recent 20 entries from the table have already been seen after a delete, we don't produce the confetti effect again. Let's take a look at Vite config. PGlite is compiled from the PostgreSQL C source code into WebAssembly. Because it's WebAssembly, we need to exclude it from dependency optimization. And so this is an important entry in the Vite config for PGlite. As mentioned earlier, this demo has configured PGlite in a multi-tab worker. Let's take a look at that file. In this file, we specify a data directory. In this case, in the demonstration, we are using as our storage method IndexedDB in the browser. This means that the click counts will survive a page refresh, and they'll be durable for the life of the application. We load up the UUID OSSP PostgreSQL database extension so that when entries are made in the click table, they automatically get a UUID. And this last line here, relaxed durability set to true, greatly speeds up PGlite in the browser. Let's take a look at the database migrations. We've loaded our migrations from this file, DB migrations client 01 initialize. Let's take a look at that file. In here, we have standard SQL, and we first create the extension for UUIDs, and we define the table schema for fruit. Because this migration runs every time, we want to write our schema in a way that will survive multiple runs. So we use the create table if not exists. We create an index on the fruit table for the at column, and we create the click table. The ID is set to UUID version 4, and the on column references the fruit table ID. We also create an index on when the click was made at, and we insert into the fruit table the emojis that we want. Let's demonstrate the effects of our schema migration. If we delete a particular emoji, the button will disappear. And upon refresh, the initializations will run again, and the peach button will return. And as we can see, as stated earlier, if we refresh the page, all the click counts are durable because PGlite in this demonstration is using IndexedDB. Thank you for watching this demonstration. Again, a link for the demo and the source code are available in the video description.